Fran.
Thank you. Right, so that was extremely smooth. So somebody, I think, said yesterday in one of the Big Data Week talks, is there anything except for ad clicks? And it can kind of feel like there isn't anything except for ad clicks in our industry, but there really is. And really what I want to talk about today is some of the uses that we found for big data other than ad clicks that we think are actually much more important and much more relevant to the world. So as Ed said, I run a startup called Mastodon C. We say we're big data done better. One of the things we mean by that is that we try and do what we do very, very well, so use the best tools and implement things very professionally. But also, we like to do projects that have a positive impact. So we would rather be working on things that have some positive impact in the world. And we use a technology called Hadoop to do that. Most of you are probably familiar with that. Another time I'll bend your ear about why Hadoop is really useful. But today I want to talk actually about the data that we've been using on a couple of recent projects, and in particular about some data from the NHS. So this talk is partly a plug for the fact the NHS Information Centre releases some incredible raw materials. And I don't know if you've seen any of these yet. It doesn't really come up on this screen, but they release raw data about all sorts of very interesting things. It's probably the only National Health Service in the world that does so. And there's an enormous amount of material there. As you'll know, if you work with data, it can be very hard to get hold of real, interesting raw data that you can work with. So either if you want to try out new modelling techniques or if you are genuinely interested in health, it's very worth having a look at what's happening with this data. So this is an example of the prescribing data that they release each month. There's about 10 million rows of data a month. Every item prescribed by every GP in the country is in this file. It's a CSV file, tells you which doctor prescribed something, what it was, how much it cost, what flavour it was. For things like surgical stockings, it tells you what size and what colour. So it's every kind of detail that you could want. So it's this incredible raw resource. And one of the projects that we've done with this is we were asked by some NHS doctors to look at this issue that the NHS has of efficiency in prescribing. So there are a number of cases, a number of types of drugs where there are generic and proprietary near equivalent drugs. Most of the time, the generic drug has just the same effect for patients, so most of the time the NHS would rather that doctors prescribed that generic one. It's about a 20th the price most of the time. And the BMJ, who are obviously far more medically knowledgeable than me, identified this as being about a 1.4 billion a year problem for the NHS. Now, it's not a simple problem to solve because it's not just a case of banning the expensive forms, because for some patients, those work really well. So you can't just take a top-down approach to trying to stop doctors doing things. They have autonomy, and so they should. They need to do the right thing for patients. However, it's very helpful to have some transparency on variation. So there are some of these drugs where we wouldn't expect for there to be any kind of variation in the level of need for the expensive or the cheap form. So if we can see where there are outlying areas, that's something quite interesting and useful to the health service. Also, the NHS has tried to tackle this locally already. So they have these people called prescribing advisors who work in primary care trusts or now in these things called CCGs. They try and persuade doctors to prescribe efficiently, to take up the latest guidance, to do the things which are deemed right by the NHS. But at the same time, there are people like drug reps who are also going around trying to persuade doctors that their drugs are very effective and are great solutions. So there are lots of different forces at work. So working with an organisation called Open Healthcare UK, we started looking at just one of, this has 10 classes in it that make up that 1.4 billion. We looked at the variation in just one of those classes, which is called statins. And this shows you the prices of different kinds of statins as of the middle of last year. The generic was £1.40 a pack. The other forms had £15 to £25 a pack price. And it's a very, very common drug. So reducing variation, if you can do so without any patient harm, is a very effective way for the NHS to save money and to instead spend money on things which genuinely help patients. So it's quite an interesting problem to start to look at. And we analysed this data and started to look at how much was going on in this class. And the statins part of that 1.4 billion is about £250 million a year. So if everyone was switched to the generic, you'd save about £250 million. About 200 million would be saved if you just switched an average proportion. So if you just switch the outliers down. If you map up where a lot of the overspending seems to happen, we can find a few big blobs. One surgery in particular was spending £20,000 a month on a single drug, which ought to be a very unusual drug, and it wasn't in that place. So you can start to find the outliers. However, this was the kind of first interesting decision point in this piece of work is there are two problems with trying to portray the numbers like this. One of them is a kind of pet hate of lots of data modelers is if you analyse the absolute number of something in the country and you draw a map, the first thing you find is where do all the people live in my country? And that's not a very useful, insightful finding. So we didn't want to do that. The other issue with showing absolute numbers on a map was we knew that this was going to be publicly visible. So what we didn't want to do was provide a hit list for somebody to go around and doorstep some doctor who may have very good reasons for prescribing a particular drug and say, you are the worst doctor in Britain, and to name and shame, because that's not the point. We know it's a complex problem, therefore we need to be a little bit careful about what we enable with the data that we present. And I think that's a key point about working with public data is that you don't know how it's going to be taken forward, so you have to be quite cautious about how you show things and how you explain what you do. So in the end, we instead showed it as a choropleth map, so showing areas, so smoothing out individual doctors' behaviours, also showing percentages rather than absolute spend, so that we didn't get that population problem. It still picks up some interesting hotspots, so some interesting areas of the country. And I think that was quite surprising to us, and it was also quite surprising to a lot of the doctors and the NHS commissioning board who looked at it, because I think they had imagined that the picture was much smoother. So they got quite excited about this way of visualising their data. And again, that was an interesting learning for us, because this was from public data, which had existed for at least 6 months before we did this in public, completely downloadable and free. It was also looking at a problem which was known. So that article from the British Medical Journal was 2011. It's been a bugbear of certain doctors for quite a long time, this variation in prescribing. So all that we did was put the two halves together with open source tools. So that was quite an interesting thing to say, is there wasn't anything secret here. All we did was come along and do something. So just take some action. And it did get picked up publicly, so we were quite relieved that we hadn't put any doctors' names on there. Daily Mail write-up was actually quite balanced, so that was good. It also got picked up by people like The Economist and Radio 4 and the FT, and they were much more sort of thoughtful and calm about the whole thing. But, lots of people read this, and lots of people were interested, so that's got to be a good thing, is provoking a conversation around these issues. And again, it reinforces the fact that you've got to be really careful about how you communicate the data. So that was a really interesting project, and it's led on to a few other things. One of the other things that we've been working on with another client is they want to look at the spread of innovation and the spread of take-up of new drugs by different doctors. And in fact, they wanted to look more broadly at the issue of take-up of new things by the public sector, and to start to say, are there certain types of people that take up new things more quickly? Can we say anything about the patterns of behaviour that we get here? And again, it's going from exactly that same raw data set, prescriptions published every month, and this time just turning it around to look at doctors' behaviour over time instead. And again, this is very, very interesting. So it's hard to know everything, so we can make statements about the patterns that we see. We can't make statements about why things happen. Same as with the prescribing variation, we can show a clear picture, but then we have to leave it to the professionals in that profession to talk about why these patterns might be. But you start to find really interesting things like looking at these survival curves, which actually are used quite a lot, by the way, in medical statistics. If you're testing a drug, you would look at a survival curve and see who lives and who dies and what characteristics seem to be associated with that. In this case, we're looking at doctors and who takes up or doesn't take up a drug, so treating that as a terminal event, that take-up, and saying what characteristics are associated with apparently a higher or lower risk of the terminal event of adopting something new. And this pointed up some really interesting patterns. So, for example, on this chart, the x-axis shows time, y-axis shows the proportion of doctors who took up a new drug, and the red line is practices which only have one doctor in them. The blue line is ones which have more than one. So you already start to see things separating out where practices with one doctor appeared to be taking up this drug more slowly in this particular case than practices with more than one doctor. So that same raw data set paints quite an interesting picture. We can start to look at who are early adopters of this. So this is who were early on, again, this same drug. Putting it on a map is kind of helpful, but it's very difficult to actually say, well, it looks kind of clumpy, but is that statistically significant? So again, you can use this survival route. This one's quite a lot messier than the other, but it seems to suggest that one of the factors on which affects adoption of new drugs in this case is how many of your neighbours have adopted it. Of course, correlation isn't causation, but we have a correlation here between those two things. So we can start to draw some really interesting patterns about doctors' behaviours and about innovation, as well as about spending in the NHS, as well as about probably a dozen other interesting, important things from this same data set. So one of the things that came up from this, and actually I'd really appreciate if people have useful comments afterwards. I don't think we've got time for Q&A, but test-driven analysis is increasingly something that is something I'm thinking about in these kind of complex projects, which is that each of these only involves a few analysts. We publish the code openly, but we don't have a concept of test suites in the same way as we do with software. So it would be, I think, really interesting and important to have some concept of rigorous testing in this stuff, because we know that all analysis and all software contains bugs, but we don't have a way to tick boxes against analysis in the same way as we do with software to try and check that it passes all known tests. So I think that's an open question, is how do we do analysis in a rigorous and open way in the same way as we do software now, while acknowledging error, but also having good processes to work around it. Now, I'm almost out of time, but just a couple of closing points, which I think are very important. First, there is a huge amount of really interesting data out there. Please take a look at it. The NHS Information Centre has very good stuff. Data.gov UK releases a lot of data. It's not all PDFs anymore. There are some actual big, raw, interesting data sets out there, particularly about government, but about lots of other things. And in my view, if you're trying to learn new techniques, far better to do it on that than on the Million Songs data set, because you might find out something interesting about the world from this. Less likely to do that by looking at what songs people listen to. So that's very cool, but it's nice to be able to have more human impact and more human stories around what you do. Also, particularly that first project, which is a very simple thing, just doing it and making things actually can have a really big impact. So we spent a couple of weeks working on that. We had no expectation of it going nuts in the way that it did, showing up on the front of the Daily Mail. So actually just taking some interesting actions can seem to lead to quite a lot of impact and quite a lot of interest. Also just being careful about how you use data, so particularly thinking about how things can be misinterpreted, and public data often contains details which are interesting and which are not there in the raw data, but which you can draw out. As we all know, you can learn a lot from data that's not explicitly stated in the data. I think as analysts, we've got a responsibility to think about how our analysis could be used or misused, because we have these skills to bring out information that other people may not have. Also, everyone really likes nice visualizations. So I think half the reason that first project got publicity was it was a really nice map. People really like playing with nice visualizations. So that is absolutely critical to having impact in your analysis, is people seeing what you do and being able to play with it and engage with it. And for people who are not analysts, that means visualizations and interactive things. So finally, we couldn't have done any of this work without an amazing stack of open tools. So I just wanted to name check some of the ones which I think are very important to us and which have been really useful. So our whole business is based around doing Hadoop systems, and it's very, very handy for big and for messy data sets. Also for this modeling, actually, we use R quite a lot. Again, another great open source tool. Those who use R will have recognized the ggplot graphs earlier on. Cascalog is a pipeline tool which you can use to munge data very well. Leaflet makes lovely maps. OpenStreetMap has all the map boundaries on it, and NHS Information Centre released the raw material. So really just wanted to point these out as an appreciation for all the incredible resources and tools that we have available. They're very effective tools, and I think we should all be using them and contributing back to them as we go, because I think that's a way to do some really great work. So I'm just about out of time, so I think that is it for me. Thank you very much.